Wow, wow. I already had people waiting for me in class. This is awesome. Hello, David. Nifemi, how are you?
Hi.
Fine, sir.
Good evening. How did your day go?
Bye, sir.
Awesome. David, how is your dad now? How is he doing?
He's doing better.
Oh, I'm so happy to hear that. I'm so happy to hear that. Please make sure you send my regards to him, okay?
Okay, sir.
Oh, awesome, awesome. Today I'm going to be treating molecular formula with you guys, okay? But before we get into that, there was something that I discovered while checking out the recording for the last class that we did, and I discovered that there was something I forgot to include in the steps for calculating the empirical formula. Can you guys see what's on the screen right now?
Yes.
Yes.
All right, beautiful. From the laws for calculating the empirical formula, there was one that I forgot to add, and that was this last one, which is the step to multiply to get whole numbers if necessary. So, for instance, now, after you have gone through all the steps for getting the empirical formula, let's say you end up with 1, and then you end up with the other number being 1.5. Instead of approximating this 5 here to become 2, what you're simply going to do is to use a number to multiply this one and this one in order to get the two of them to be whole numbers. Let's see this example on the screen right now. Can you guys hear me?
Yes, sir.
All right, so what I want you guys to do right now is to write out all these steps because we're going to apply them to a question before we move into this the topic that we have for today. Don't worry, today's lesson is not going to be very long, okay? So write all the steps on this screen right now. When you're done, let me know and then we'll proceed. Francis, how are you? Nifemi, how are you?
Fine.
Francis, you're welcome.
Thank you, sir. Good evening, sir.
Yeah, you're welcome. Are you done writing it? Are you guys done writing?
Okay.
Are you guys done writing?
No, sir.
All right, when you're done, just let me know. And then we'll solve one question before moving into molecular formula for today's class.
Yes. It's not happening again. It's like for no service. So I'm done.
Okay, how about other people? Are you guys done as well?
No.
Okay, so let's wait for the others to get done. Are you guys done writing?
Yes, sir.
Who else is still writing? 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 David, are you still writing?
No, sir.
Nifemi, are you still writing? Nifemi, are you there? Are you still writing?
No, sir.
Okay, you're done, right?
Yes, sir.
All right, awesome. So let's get into that step for calculating the empirical formula. So I guess you guys can see what's on the screen. Is that correct?
Yes, sir.
All right, beautiful. So we have the steps for calculating the empirical formula on the screen right now. So I'm going to look at one question where we're going to apply all of them, and then we are going to solve them step by step. The question says lead oxide is a compound. A sample of lead oxide contained 6.21 grams of lead and 0.72 grams of oxygen. Work out its empirical formula. All right, so somebody read out the steps for me and let's do them one by one. Step number one, what are we doing?
Obtain the percentage composition of each element.
Okay,
If the values are given to you as percentage,
thank
and
you.
convert it to percentage grams.
Thank you very much. Now, the values are not given to us in percentage. Is that correct?
Yes, sir.
Good. So what are we going to do now?
We convert them to moles by dividing them by the atomic mass.
All right, good. So let's list out the elements that we have. We have the first one, which is lead. Lead has the symbol Pb, right? What
Yes,
is the
sir.
mass of lead that was given to us? We're given 6.21 grams. The second element that we have is oxygen. Oxygen has the symbol O. The mass of oxygen we were given is 0.72 grams. Thank you very much. So the next thing to do is to convert it to number of moles. How do we do that? We divide by the atomic mass. The atomic mass of lead is 207. So we're dividing it right now. And the atomic mass of oxygen is 16. So on both ends now, let's punch our calculators and get our individual values. For lead, we have 6.21. I hope we're all following. Divided
Yes,
by
sir.
207. That gives us 0.03. 0.03. How about the second one? The second arithmetic, 0.72 divided by 16. That gives us 0.045. Now, what is the next thing to do?
Next thing to do is divide the values by the smallest quantity.
Thank you very much. So my question is between this guy over here and this guy over here, which one is the smallest?
0.03.
Thank you very much. So that means we're going to divide all through by 0.03. So we have divided by 0.03, and then we have divided by 0.03. So let's get our values. This over here becomes 1, and this over here becomes 0.05 divided 0.045, I beg your pardon, divided by 0.03. That gives us
1.5.
1.5. So now, what is the next step or the last one?
Multiply to get whole numbers if necessary.
Thank you very much. Now, what this means is that after you have divided by the smallest number, if what you are getting is not a whole number, this one over here is a whole number, but this one is not a whole number because of there is a decimal point over here. I hope you can see it.
Yes, sir.
Beautiful. So what that step is simply saying is that you will multiply in order to make sure that everything here is a whole number. So my question is, what number can we use to multiply 1 and also multiply 1.5 that will give us whole numbers?
2.
Yes, who wants to answer that question?
Sir, me,
Yes.
Francis.
Okay, go ahead.
Two.
We can use
If you
two.
must. Yes, sir.
Thank you very much. We can use two. So if we use two, now any number at all you want to use is allowed, okay? Just make sure that
Yes,
when
sir.
you multiply, you divide it to the lowest term. I'll show you an example. If we use 2, 1 times 2 is equals to 2 over here. 1.5 times 2 gives us 3. So
Three.
we have 2 ratio 3. If we had used another number, let's say instead of using 2, let's say we use like 10. So this becomes 1 times 10 equal to 10. 1.5 times 10 is equal to 15. We'll have 10 ratio 15. We'll divide this to its lowest term. What number can divide both 10 and 15? 5 can divide the two of them. If we use 5 to divide the two of them, we will have our 2 ratio 3, which is the same thing that we got when we used 2 to multiply. Are you all following?
Yes, sir.
Beautiful. So what number are we using to multiply? We are using 2. 1 times 2 gives us 2. 1.5 times 2 gives us 3. So our
Three.
final ratio becomes 2 ratio 3. So therefore, lead now takes the number Pb2 and
Two.
oxygen takes the number O3. Did you all see how it was done?
Yes, sir.
Yes, so I thought to include that final step in that I didn't include in our previous class. So now that we have done that, let's get into what we are studying for today. Today we're going to be looking at the concept of calculating the molecular formula. Can you all see what's on the screen right now?
Yes, sir.
Beautiful, beautiful. So now, it is possible that when you calculate the empirical formula of a compound, you can use that information to get the molecular formula of a compound. In our previous class, we talked about what the molecular formula of a compound is. Does anybody want to remind us what the molecular formula of a compound is?
Molecular formula.
Yes.
Molecular formula is the actual number of atoms of of each element of the compound.
Oh, thank you very much. So let's refine that definition very clearly. A molecular formula is simply a formula that tells us, you might want to write this down, that tells us the actual number. It tells us the actual number of atoms of each element in a compound. Please go ahead and write this down. This definition is very, very important. The molecular formula of a compound is actually the formula that tells us the actual number, the real number of atoms of each element in a compound. So for instance, let's say the molecular formula for water, which we all know as H2O. This formula is telling us the exact number of each atom and each element present in the compound. So this molecular formula is telling us that there are two elements present, hydrogen and oxygen. Not only is it telling us the elements that are present, it is telling us the number of atoms of each element that are present. So for instance, you can see over here that there are 2 atoms of hydrogen, and then there is just 1 atom of oxygen. Are you all following?
Yes, sir.
Beautiful. Can you all hear me? David, Francis, and Nifemi, can you all hear me?
Yes, sir.
All right, beautiful, beautiful. So now that we know what the molecular formula is, here is how we can use the empirical formula to get the molecular formula. So first things first, the molecular formula is a multiple of the empirical formula, and it represents the actual number of atoms. So now here is the mathematical expression that we can use to get the molecular formula after calculating the empirical formula. Can somebody read it for me?
Molecular formula is equals to empirical formula times N,
Thank
where
you
N
very
is equals
much.
to molar mass of compound or empirical formula mass.
Okay, so this over here is the divide sign. Okay, divided by. So what we're simply saying is when you have the molecular formula, or when you have the empirical formula rather, and you are asked to calculate the molecular formula, this is the mathematical expression that you use. Okay? The molecular formula is equal to the empirical formula multiplied by N. And I'm going to be solving an example to show you guys how it plays out, okay?
Yes, sir.
All right, beautiful. And this N also has what it stands for. N is equal to the molar mass of the compound divided by the empirical formula mass. So here are the steps to use to get the molecular formula of a compound when you have the empirical formula available. Step number 1, David, can you read it out for me?
Calculate the empirical formula mass.
Thank you very much. What they mean over here is when you have the empirical formula for a compound, for instance, the one we just calculated was Pb2 and O3. This was the empirical formula for the compound we just calculated, right?
Yes, sir.
Good. So if we have been asked to calculate the molecular formula, what we will simply do is to calculate the formula mass of this. How do we do that? We'll simply use their atomic masses. Remember, for lead, Pb, the atomic mass is 207. Is that correct?
Yes, sir.
And for oxygen, the atomic mass is 16. So
16.
we'll simply come here to the empirical formula and put in their values. So we have lead over here, which is 207 times, we have 2 atoms of lead over here. I hope you can all see what I'm doing.
Yes, sir.
Good. I'm showing you how to calculate the empirical formula mass. So it becomes 207 multiplied by 2 plus, we have oxygen over here. What is the atomic mass of oxygen?
16.
Thank you very much. So we have plus 16 times the number of atoms of oxygen that we have, which is what?
3.
Thank you very much. So this is how to calculate the empirical formula mass. So what is going to happen is we have 207 multiplied by 2. That gives us 414. 414 plus 16 multiplied by 3. That is 48. Somebody go ahead and add these two for me and tell me what the answer is. 414 plus 48.
462.
462. So that is step number 1. So step number 2 says determine the multiple n. How do you determine the multiple n? Let's backtrack to the formula that I showed you. This formula that I showed you, molecular formula is equal to empirical formula times n. So this n, you get it by saying the molar mass of the compound divided by the empirical formula mass. Don't worry, we'll solve one question now and we'll see how everything plays out. Is everybody on the same page? Are we all following?
Yes, sir.
David, are you there?
Yes.
Yes, sir.
Nifemi, are you there as well? Does anybody have any question thus far? Nifemi, David, Francis, anybody with a question?
No, sir.
All right, so here is what I want you people to do. Write down these steps for calculating the molecular formula. When you're done writing it, let me know and then we'll solve the first question. And then after that, I'll give you guys an assignment and we'll be done for today.
So I've written the steps.
Okay, David, have you written the steps as well?
Yes, sir.
How about you, Nifemi? Have you written the steps? Okay, beautiful, beautiful. So now that you've written the steps, let's solve this question. The question on the screen right now starts by saying, if the empirical formula of a compound is CH2O, this is the empirical formula, and its molar mass is 180 grams per mole.
So,
Hello? Are you there? Francis, what's that? Is there any issue, any challenge? Okay, let me reread the question one more time. I was saying this question on the screen is saying if the empirical formula of a compound is CH2O and its molar mass is 180 grams per mole, find its molecular formula. So now What is step number 1?
We should calculate the empirical formula mass.
Thank you very much. And they have told us that the empirical formula is CH2O. So now let's calculate the mass of this. What am I going to do? I'm going to outline the elements C plus H, H2 plus O. So that gives me, what is the atomic mass for carbon in this question?
(12.01).
Thank you very much. So this gives me 12.01 plus, what is the atomic mass for hydrogen?
1.008.
Thank you very much. 1.008. Now, we have not just one atom of hydrogen, we have two atoms of hydrogen. So what we're going to do is say this 1.008 will now be times 2. Are you there?
Yes, sir.
Yes, sir.
Good. Plus oxygen. What is the atomic mass of oxygen?
16.
Thank you very much. 16. So at this point now, we're going to say 12.01 plus 1.008 multiplied by 2 plus 16. So what's the answer? I hope you guys are punching your calculators as well. This should give you 30.026. Somebody please confirm for me. Yes, did you get this answer? 30.026. Somebody confirm for me.
Yes, sir.
All right, beautiful.
Correct.
So step number 1 now, we have gotten it 30.026. The empirical formula mass is 30.026. Let's keep that one aside. Step number 2. Can somebody read out what step number 2 is for us?
Determine the multiple.
Okay, what is the multiple? N. Now, what is the formula for getting the multiple? N is equal to what?
Molecular formula over
You can see it here. N
Mo-
is equal to molar
molar
mass
mass
of
of compound.
compound divided by empirical formula mass. So now, what is the molar mass of the compound?
30.026.
What is the molar mass of the compound? The molar mass.
180 grams
180
per
grams per
mole.
mole.
Thank you very much. So we have 180 divided by the empirical formula mass, which we just calculated over here. Can you all see that?
Yes, sir.
So 180 divided by 30.026. Let's punch our calculators. Now we have 180 divided by 30.026. That gives us
5.994.
Thank you very much. 5.9948. If I approximate, what value am I going to end up having?
6.
5.995.
Thank you very much. This is going to give me the value of 6. So I have my multiple now. Okay, so I can hear some people arguing 5.995 for my. If we approximate, okay, this becomes 5 over here. And then this 9, if I approximate again from 5, everything rounds up to become 6. So my n, or my multiple n, is equal to 6. And the empirical formula mass is 30.028. So now what is step number 3? Okay.
Multiply the empirical formula by n.
Okay, step number 3. Multiply the empirical formula by n. What is the empirical formula? CH2O. And what is my n? 6. So what I'm going to simply do is say multiplied by 6. Can you all see what I'm doing over here?
Yes, sir.
Good. So
Yes, sir.
thank you very much. So when I multiply, this becomes C times 6, and then this becomes H2 times 6, and then this becomes O times 6. So let's get our values now. C times 6 gives me C6. Is that correct?
6.
And then H2 times 6 gives me
12.
what? H12. And then O
12.
times 6 gives me what?
6.
Thank you very much. This is my molecular formula. C6, H12, and O6. Who can tell me the name of this compound?
Carbohydrates.
The name of the compound.
Glucose.
Thank you
Glucose.
very much. This is glucose. This is the name of the compound. So the empirical formula for glucose is CH2O, but the molecular formula is C6H12O6. Now, from our definition of what the empirical formula of a compound is, this is showing us the ratio of the elements that are present. It is telling us that we have 1:2:1 of carbon, hydrogen, and oxygen. And this is the actual molecular formula. It is telling us that we have 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. Any questions?
No, sir.
No,
All
sir.
right. So you guys go ahead and write this question down. This is your assignment. Yes, Nifemi, you raised your hand. Do you have any question? Nifemi, your voice is not clear. Can you please type the question in the chat box? If you could type out your question, I'd really appreciate. But for those of you who can hear me clearly, this is the assignment on the screen right now. I want each and every one of you to write it down. And then,
Sir,
yes,
well, I have a question.
yes, what's your question?
I was not here throughout the class, so can you please solve that example again?
Okay, who is speaking?
Me, David.
Okay, David, don't worry. I'm going to send, this class is currently being recorded, okay? So I'm going to send the link for the replay of everything that we did throughout today's class. So you just settle down, watch it, and then the assignment is going to make sense to you, okay?
Okay, sir.
All right, no problem. Okay, Nifemi is saying that she did not get step number 3. Okay, so let's do step number 3 again. Or let's solve this question from the beginning all over again. So everybody now pay attention. To get the molecular formula of a compound when the empirical formula is given, there are 3 steps. What is step number 1? Please read it out for me.
Calculate the empirical formula mass.
Thank you very much. Step 1, calculate. Let me write it out. Calculate the empirical formula mass. Now, my question to you is, what is the empirical formula now from this question?
CH2O.
Thank you very much. CH2O. So this is how we calculate the empirical formula. The empirical formula is showing us that we have carbon plus hydrogen, and hydrogen is not just one atom. Hydrogen are actually 2 atoms. So we have H times 2 plus oxygen. So carbon has an atomic mass of 12.01. This becomes plus. Hydrogen has an atomic mass of 1.008 times 2, and then plus oxygen, which has an atomic mass of 16. Did you all get that step?
Yes, sir.
All right, so Nifemi, now I want you to calculate this arithmetic, 12.01 plus this, and tell me what the answer is. I'm waiting for your response, Nifemi. So if you punched your calculators well, you would end up with this value. Yes, correct. 30.0.30 30.026. So now we've done step number one. We've gotten the empirical formula mass. Let's write it down. 30.026. Now, what is step number two?
Mm. So okay.
Who is reading out step number two for me? Yes, who is reading out step number two? I can't hear any of you speaking. David, do you mind reading it for me, please?
Okay.
Yes.
Step number two, you divide by smallest.
No. This is for empirical formula. Here is step number two. Determine the multiple n. And I told you all that to determine the multiple n is equal to the molar mass of the compound divided by the empirical formula mass. Don't worry, if this doesn't make sense to you, this class is being recorded, okay? So you just go back and watch it. So the molar mass of the compound is 180 grams per mole, and the empirical formula mass is 30.026. If you do this arithmetic, you're going to end up with approximately 6 as n. So your n, which is the multiple, is equal to 6. So now, step number 3 that you said you did not get, Nifemi, is what we're about to execute right now. Who is reading out step number 3 for me, please? What does...
Multiply the empirical formula by n.
Thank you very much. Multiply the empirical formula by n. Our n is equal to 6. The empirical formula is CH2O. So now let's multiply it by 6. Multiplying it by 6 means I'm going to have C times 6, and I'm going to have H2 times 6, and I'm going to have O times 6. So finally, I end up with this. C multiplied by 6 gives me C6. H2 multiplied by 6 gives me H12, and O multiplied by 6 gives me O6. This is the molecular formula. Nifemi, do you get it now?
Yes, sir.
Oh, Nifemi, I just saw your message in the chat box that my voice was breaking. Are you hearing me clearly now?
Oh,
Is my voice still breaking? Oh, so sorry about my voice breaking. But I think other people can hear me clearly. I think it's a network glitch from your end. But if you cannot hear me clearly, don't worry. This class is being recorded. I'm going to upload the video to my YouTube channel and send you guys the link. So everybody right now, write the assignment on the screen. So once you're done writing it, let me know.
Oh, done. So I'm done.
Okay. Uh, Francis, you're done. Let me ask the others if they are also done as well.
Just so.
Are you guys also done? David, are you done too?
No, still writing.
Okay, okay,
I'm done now.
okay, beautiful. Nifemi, I hope you can see what's on the screen. Are you still writing? Our new student in class, Oremeyi. I hope I'm pronouncing the name correctly. Pardon me if I'm not. Are you done writing the question on the screen? Maybe she's not hearing me clearly. Okay, so um, for all of you who are done writing the question, I want to say a very big thank you for logging on with me on today's class, where we've talked about the empirical formula of a compound and the molecular formula of a compound. I want to see this assignment before our next class, which is going to be on, if I'm not mistaken, I think that's Friday. Yes, Friday. Friday, where we're going to be taking something absolutely interesting. So until then, I want you to go ahead and do this question. And if there is anything you are not clear about in this class, please don't hesitate to reach out to me, okay? You have my DM. I'm always open to answer your questions. Yes, somebody was asking a question. What's that? Okay, in the absence of any question, we're done for today. So I'll just quickly upload this video and send it to the class. Just watch out for it. All right, bye everyone.
Thank you, sir.
You're welcome. Bye.